Hello viewers, this is Ronald taking you through today's tutorial, and this video we're going to talk about the solutions to A-level Sub Math for UNEB 2019, and particularly we shall talk about questions 13 and 14. So these are the very questions I left you with in the previous video, and I believe by now you have already tried them out and you're waiting to mark yourself and check your progress. So that was question 13 and this is question 14. Each question was carrying 15 marks. So we are going to start with question 13 and see how it is done. So question 13 says the table below shows the heights of to the nearest centimeter and masses to the nearest kilogram of 10 students A to J. So these are the students A to J, these are the masses, and these are the respective heights. Part A, Roman 1. Plot the given data on a scatter diagram. Roman 2. Draw a line of base feet on the scatter diagram. And Roman 3. Estimate the height of a student whose mass is 60 kilograms. That is 8 marks. Then part B. Calculate the rank correlation coefficient for the data. Comment on your result, and those are 7 marks. So in total there are 15 marks. Now let's see how those marks can be got without leaving any. So first of all, you have to know how to rank. Now how is ranking done? Ranking, just go on your question paper before you write the solution. Go on your question paper and start to rank on that question paper. So let us rank on our question paper. So this is the table. What we are going to do, ranking, the highest value is given the smallest rank, and you ascend as, and you keep on descending. Now for example, if you like, let's start with the ranks for mass. Now the ranks for mass, you look for the highest. If you look at all these values, this is the highest, but there are two values with 68. What do you do? It means that if they are not equal, one would have taken position 1 and the other would have taken position 2. But since they are similar, both values must get one similar rank. No, and that rank will be their average. So we shall come here and say 1, which will be which is the would-be position for one value, and 2, which is the would-be position for the other value. Divide by 2, get 1.5. So both values will get rank 1.5 and 1.5. Now the next largest is what? Is 66. Now 66 will be rank 3 because 1 and 2 have been taken, so the next rank will be for 3. So this is the 3. Next will be 64, it takes rank 4. Next is 63, takes rank 5. Next is 58, takes rank 6. And next is 57, but you realize that 57 there occurs twice. There's 57 and this 57, meaning one value would have taken 7 and another one would have taken position 8. But since they all must have the same rank, you are going to get their average. So when I say 7 plus 8 over 2, I'll come up with 7.5, meaning both 57 must have 7.5, 7.5. Now after 57, we shall go to 53. Now 53 takes rank 9 because 7 and 8 has been taken, so we are going, the next will be 9. Now after this, the next one will be 52, which is 10. So we have finished the rank for mass. Now let's go to the rank for heights. Rank for heights, the biggest is this, which it takes rank 1, followed by this, rank 2, followed by this, rank 3, followed by this, rank 4, followed by this, rank 5, and followed by this, rank 6, followed by this, rank 7, followed by this, rank 8, followed by this, rank 9, and followed by this, rank 10. So that's how they rank mass and height. Now that we know how to rank, let's go to our solution. So the first thing to do before anything is to tabulate, is to draw a table. Now that table will help us so much in all the parts. So this is the column for students and this is the column for x. Now x will be the values for the mass, and y will denote the values for the height, by this time in column form. So after doing that, you are going to sum all these ones to come up with this, and sum all these ones to come up with summation of y. Now these ranks for mass which you got here will be denoted by this Rx, and also these ranks for height which you got here will be denoted by Ry. So these are the values for ranks for y. Now after that, we need a column of D. D means difference or deviation. Now how is it got? We shall say Rx minus Ry. So when I say this minus this, I'll come up with 1. This minus this, I'll come up with 0.5. This minus this, I'll come up with 1.5. This minus this is 0. This minus this is -1. This minus this is -1. This minus this is 2. This minus this is -1, and so on up to the end. Now this squared means you are going to square these values. So 1 squared is this 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 squared is this, and this squared is this, and this squared is that. Now after that, you are also going to sum up all these values to get the summation of this squared, which will be 13. So this table is very important in all the parts we are going to answer in this question. So now after drawing that, we shall come and say part A, Roman 1. What does it say? Plot the given data on a scatter diagram. Now for you to draw a given data on a scatter diagram, you have to know something. You have to know the mean point, because in Roman 2 they want you to draw the line of best fit, and we know that line of best fit must pass through a mean point. So what we are going to do, we are going to first calculate our mean point. Mean point x coordinate for the mean point will be this over the total. Now n will be the number of pairs, which is 1 2 3 4 5 6 7 8 9 10. So we shall say this over 10 to come up with this. Mean for y will be this over that 10 to come up with that. Now the coordinate for the mean point will be 60.6 156.9. Now before we go to the next slide, let us see how many marks we have got in this slide. So the first mark is for the rankings of x, and the second mark is for the rankings of y. The third mark is for these values of d squared, and this one is for you to sum them up, and this one is for the mean. So basically we've got 1 2 3 4 5. Okay, now that we have drawn the table and got the mean point, we can now answer very well. Part A says plot the given data on a scatter diagram. For you to draw, you have to first look for the scale. Now how do you get the scale? The first thing to do on a graph is to get a long ruler, draw the vertical axis while leaving 1 centimeter. As you can see, 1 centimeter has been left this side, and I've drawn the vertical line to mean the vertical axis. Leave 1 centimeter still on the horizontal part, and draw the horizontal line to mean the horizontal axis. Now after that, before anything, we are going to demarcate leaving intervals of 2 centimeters as I've done here. Do the same for the horizontal part. After that, the next part is to get the scale. So how is the scale got? The scale is got using these values, but the formula for scale is highest value minus lowest value over number of spaces. Now the highest value, if you look at these values, which we are going to plot, for example, let's first remove this. These values, the highest for the horizontal, and for the horizontal, the highest value will be 68 and the lowest will be 52. So we are going to say 68 minus 52 to get this minus that. Now the number of spaces is got from this. You are going to count 1 2 3 4 5 6 7 8 9 spaces. So 9 spaces on the horizontal. So that means that we are going to come and say 68 minus 52 over 9 to come up with 1.7778. Now we're going to look for a value which is exactly equal to this or greater, just greater than it. So from 1 we go to 2, meaning that our 2 will be our horizontal scale, meaning each 2 centimeters will represent 2 units. For the vertical part, still go back to the east and count these spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are 11, meaning that in our scale we are going to see highest value, which is 172, and the lowest value, which is 139, and the number of spaces, which is 11. We shall get 3, but 3 is not here. But what we know that from 2 we go to 5, therefore our vertical scale will be 5. Now that you know the scale, we are good to go. Now let's get started. 1, you must have your graph ready with you. Next is to use the long ruler to draw those axes, vertical and horizontal. And before anything, you have to demarcate leaving intervals of 2 centimeters. So let's do that for the horizontal axis, which is that, and also do the same for the vertical axis. So after that, next is to now feed in your demarcations. We already know the scale for the horizontal is 2, 2, vertical is 5, 5. So we shall do that very fast. So let's feed in the values for the horizontal part. Intervals of 2, 2. So I think I see 2 centimeters represent 2 units. And also label it. Label your horizontal axis as height. Do the same for the vertical. Feed in the values. Interval, what 2 centimeters represent 5 units, and also label your vertical axis. Now that we know that, we have to now go and plot. These are the values we are going to plot. So first of all, you have to plot 53 corresponds with 148. So come and look for 53 here, and also look for 148, which is somewhere here. So what you do, you plot that point. Then do the same. Now we have plotted that one. Go to 68 corresponding with 172. So that will be this point. So 68 corresponding with 172. Next is 53 corresponding with 156. So come and look for 57 horizontal. Look for 156 here. Plot that point. Next is 52 corresponding with 139. So look for 52 and 139, which is that. Next is 66 corresponding with 163. So 66 with 163, which is that point. 64 corresponding with 158. Look for 64, that will be the point. Then 63 corresponds with 168. So look for 63, and that will be the point. 58 corresponds with 151, so look for 58, and that will be the point. 57 corresponds with 144, so look for 57, that will be the point. 68 corresponds with 170, so that will be the point. So you have plotted all the points, but after plotting all the points, you have to remember to include the mean point. So basically what you have done, you have answered part A, which says that plot the given data on a scatter diagram. Now the Roman 1 is done. Now Roman 2, they want us to draw a line of base fit. Now for you to draw a line of base fit, you have to also add a point for the mean position. So that point is that point, and it is 60.6 and 156.9. So after adding it there, you have to remember that the line of base fit must pass through this mean point and any one or more points, but leaving equal or almost equal points on either side. So when you follow that rule, we shall see that our line of base fit will be that. Now I think I can say that it has passed through the mean point and 1 point, but it must leave equal or almost equal points on either side. So let's see. For this side, it has left 1, 2, 3, and 4 points on that side. What about this side? There is 1, 2, 3, 4, 5. Now these are almost equal because the difference is 1. 5 minus 4 is 1. So that means that our line of best fit is okay. So now we have finished. Now I've finished Roman 2. Now we shall go to Roman 3. Roman 3 says, estimate the height of a student whose mass is 60 kilograms. Remember, mass was on the horizontal and height was on the vertical. So what we are going to do, go on the horizontal, look for 60 and draw a vertical line up. So that is our vertical line. Now where that line meets this line of best fit, take a horizontal line to meet the vertical axis. So when you do that, we shall take this vertical line to meet this vertical axis. Now this value is read off, and that will be the required height. Now when you read off that value will be 155.75. Now because of that value is 155.75, you'll come here and conclude that Roman 3, the estimate height of a student whose mass is 60 kilograms is 155.75 centimeters. We have been able to get the answer, part A, the whole of it, which is 8 marks. Now we are going to part B, which says calculate the rank correlation coefficient for the data and comment on your result. Now before we go to part B, let us see how marks can be awarded for this part A. So in this case, we shall see that this B1 and this B1, these 2 marks are for the horizontal axis well labeled and also vertical axis well labeled. Those are 2 marks. Then 2 marks for plotting all those values correctly, including the mean point. This B1 is to draw a reasonable line of best fit through the mean point. Remember we said a reasonable line of best fit must leave equal or almost equal points on either side. So if I see that, that is how the B1 comes from. Now the M1 is for estimation. For you to draw these dotted lines, you don't just read off and write this. You have to show these dotted lines. So showing these dotted lines, that's how the M1 comes from. And this A1 is for you to state, but for you to get that A1, remember, estimation line must be seen. So you don't just use your eyes to look at to find out this value. You have to use your ruler to draw those 2 dotted lines. So before I give you this mark, I have to first look, see if these lines are there. So now we shall go to part B. Part B says that calculate the rank correlation coefficient for the data, comment on your result. So first of all, rank correlation coefficient is given by this formula, 1 minus 6 times summation of d squared over n, where n means number of pairs multiplied by n squared minus 1. Now remember, previously we already calculated this, draw this table. Now n will be 10. For example, number of pairs is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10 and summation of d squared is 13. So what do? We shall come here and substitute. Where there is summation of d squared, we shall put 13. Where there is n, we shall put 10. And when you simplify, we shall get 0.9212. So basically that was the rank correlation coefficient which they wanted, but they also wanted you to comment. Now how do you comment? For you to comment, you must know this calculated value and the number of pairs. So when you know that, you'll come here and say number of pairs are 10, so this is 10, and we are interested in the Spearman's rank correlation coefficient. So this one ignore 8, this one ignore 8, but these ones we need them. Now what you're going to do, you are going to compare this table value and the calculated value. For example, our value is 0.9212. So if I want to comment at 5%, I'll come and look for this value. 0.9212 and this one, we realize that the calculated value exceeds this stable value. And remember, they told us that significant if this calculated value exceeds this stable value. So now, because the calculated value exceeds, we shall come and comment that significant at 5%. But also, you can also comment at 1%. For example, compare this 0.79 with the calculated value, you realize that the calculated value is 0.9212 and the stable value is 0.79. That means that the calculated value exceeds this value at 1%. Therefore, because it exceeds, you come and say significant at 1%. So basically, that's what they wanted in part B, and let's see how marks can be awarded. So those are the marks. We are remaining with only 3 marks. Remember, the 4 marks we already got in this table: 1, 2, and 3, and 4. So that means that to make 7, we are left with only 3 marks. Therefore, we shall come. These will be the 3 marks which were remaining. So we shall come and say the first mark is for substituting into the formula, and the second mark is for you to calculate to get that value, and third mark is for you to comment. But note, only one significant level. Some students, because they didn't specify to comment whether at 5% or 1%, what they do, they give both comments. They'll come and say significant at 5%. After that, they also say significant at 1%. That will be wrong, because the question said comment. They didn't say comments. It's only one comment. Therefore, you have to choose either you comment at 5% or you comment at 1% for you to get this last mark. Now we shall go to question 14. Question 14 says a car of mass 1,200 kilograms has a maximum speed of 180 kilometers per hour on a level road. When the power of the engine is 50 kilowatts, when the car ascends an incline of 1 in 5, note that word 1 in 5, with the same engine power, note that word also same engine power, the resultant force is 1648 newtons. So I think when I say that I've underlined it, and there's a reason why I've underlined it. I'll tell you why. Determine the part A resistance force along the level road. So I think let's first work with this part A, which has 5 marks, and see how those 5 marks can be got. So first of all is to convert this speed of 180 kilometers per hour to meters per second to get 50 meters per second. Next is to get the forward force. Remember, we are given power and we know the speed, and we know that power is equal to force times velocity. So that means that forward force will be equal to power over velocity, which is 50,000 watts over 50 meters per second, to give you 1,000 newtons. After that, you have to remember that at maximum speed, acceleration is 0, and when you know that, we shall come and draw our sketch diagram whereby this acceleration is 0, this is the forward force, and this is the resistance to which they want, and this is the weight of the car. Now after drawing that sketch, we are now going to resolve horizontally. Resolving horizontally means you look at this, it's going in this direction, meaning 1,000 minus F will be equal to MA. Therefore, we shall come and say 1,000 minus F is equal to MA. But I know my A is 0. Therefore, I'll come and say substitute. When I substitute here, I'm left with only one unknown, which is small f, and that is the resistance they want. Now, when I make F the subject, I'll come up with my resistance as 1,000 newtons. So basically, that is what they wanted in part A. Now, let's see how those 5 marks can be got. So the first mark is the conversion, for you to convert from kilometers per hour to meters per second. This one is for getting the forward force. This one is the correct force diagram drawn using a ruler. This one is for resolving, for you to resolve, and this one is for the value of resistance. So now we shall go to part B of the question. Part B says, find the maximum speed of the car up the incline, and they give it 6 marks. Maximum speed, you have to remember that at maximum speed acceleration is 0, but here they told us that the incline is 1 in 5. What does that mean? It means that arc sine 1 over 5 will give you the incline, which is 11.5370. Now that I've got the incline, I can now draw my sketch. So this is the sketch. It is going upwards, but since speed is maximum, acceleration will be 0. And this is now the forward force, new forward force on the incline. The resistance is the same, which is 1000 newtons. And this one, these forces are dotted. Why? Because this force and this force is a resolved part of this weight. So note that this force component of weight along the plane and component of weight perpendicular to the plane must be dotted. So after drawing that sketch correctly, next is to resolve along the plane. When I resolve along the plane, I realize that this is 0, meaning that this F1 is equal to this plus that. So I'll come and say F1 is equal to 1000 plus 1200 G sine 11.537. But I know that my G is 9.8 and my sine this is equal to 1 over 5, so I'll come and substitute. And when I simplify, I'll come up with F as 3,352 newtons. So I've got the forward force. Next is to get the speed which was required, because in the question they said find the maximum speed up the incline. I know that maximum speed is equal to power over the forward force, which will be power was 50 kilowatts, which is 50,000 watts, over forward force, which is 3,352. So when I use a calculator, I'll come up with my maximum speed as 14.9165 meters per second. Now let's see how marks can be awarded. So this first mark is for you to get this inclination, and the second mark is for you to draw a correct force diagram with a ruler. So note that force diagrams are drawn using a ruler. This mark is for resolving, and this mark is for getting the value of F. This one is for substituting the expression for speed, and this one is for the maximum velocity. So now we shall go to part C. Part C, they say that find the acceleration of the car up the plane when its speed is 8 meters per second. So we know that when the speed is 8, the forward force will be power over speed, which is 50,000 over 8 to give you 6250 newtons. After that, I'll now draw my sketch whereby my forward force is now 6250 newtons, and the resistance is still the same, 1000 newtons. The component of weight along the plane and perpendicular to the plane, and they must be dotted. Now this one, there is an acceleration, and that acceleration is not 0. So what we shall do, we are going to resolve along the plane. When I resolve along the plane, this acceleration is going this side, so I'll say this minus these two will be equal to ma. So I'll come and say 6250 minus, in brackets, 1000 plus 1200 G sine 11.537 is equal to ma. And then I substitute to come up with this part, and when I simplify further, I'll come up with my value of A as 2.1415 meters per second squared. I think that's what they wanted, the acceleration of the car up the plane. I think we have realized that why I underlined this part. I underlined it because it was not used anywhere. So whether this part was there or it was not, the solutions would have come out. Now let's see how marks can be awarded. So first mark is for getting the forward force, the second mark is for the correct force diagram drawn with a ruler, third mark is for resolving, and lastly for you to simplify to get the acceleration. So I believe by now you have checked your progress and done corrections where need be. What I'm going to do, I'm going to leave you with 4 questions, but this time they are section A questions, meaning each question will be carrying 5 marks. And let's get started. So those are the questions, 4 questions you can try out, and in the next video their solutions will be available. Otherwise, thank you for watching, and if you have not yet subscribed, please click on that subscribe button below this video so that you can get notifications and updates on each video that I upload, so that when the next video for solutions comes out, you'll be able to be aware of it. Otherwise, thank you for watching, and if you know any student who is not yet on this platform, you can share this link with them via WhatsApp and via Facebook and or via any social media, so that they can all benefit as a family.